Yes, sir.
We started off with triangles, and we saw that in any triangle ABC, there are three angles and three sides. CAB, three angles and three sides. And we also found
Yes,
that
sir.
there is an interesting relationship which is called the sine rule, which is any side over the opposite angle is equal to the ratio of the others, right?
Yes,
And
sir.
why is this important? Because we have to calculate the angles and the sides. So we found two cases. Case 1 was when two angles plus any one side is given, then we can find out all the others using the sine rule. Kushal, did you say something?
No.
Okay. So this is my case 1. Now, we also had seen another case, case 2, where this is applicable, where we have two sides plus one angle, which is not the included angle, right? Not the included angle.
Yes, sir.
So that means like A, B, and A or B. Then we can find out the rest. Correct? Because if two sides are given, right, we can find out the other angle and therefore the third angle, and then we can find out the third side, right? Similarly, if two angles are given, so then we have two angles, we can find out the third angle, and any one side given means we can find out the other two, right? So these are the two cases that we discussed
Yeah.
yesterday. However, we understood that there are two more combinations which we have to deal with. Case 3 is when we have all three sides given, right? What do we do then, right? And case 4 is the exception to case 2, which means two sides plus included angle, right? So for this, we cannot use the sine rule, correct? So what will we do in this case?
Yes, sir.
That is the question. Okay. So for defining the sine rule, what we had initially done was we had dropped a perpendicular from A on BC, right? That's what we had done.
Yes, sir.
So we will still do the same thing. We'll still do the same thing, and we'll call this point as D, right? So when we had defined the sine rule, we had equated H with A, B, and C. That's how we got the sine rule, right? Now we will do
Yes,
the
sir.
reverse. So if I leave out H, there is one other side in this triangle, which is CD, right? In triangle
Right.
ACD, there are three sides. AD, which is the height, DC or CD, and AC. Now AC is a side of the bigger triangle, so this is given. So we have to use the other side, which is DC, right? Or CD. Now what is CD? In terms of side ABC and angle ABC, how can we define CD? What is
It's
CD?
a fraction of CB. It's not always going to be half, but it's a fraction of CB.
Yeah, so I'm trying to define CD in terms of A, B, C and angle C, A, B. Any combination of this, right? So in triangle ACD, which is a right angle triangle, you can see that cos of angle C is equal to what? What is cos of angle C? Cos is adjacent by hypotenuse, correct?
Yes, sir.
Right? So what is
Yes.
adjacent here?
CD
CD.
over B.
And hypotenuse is
B.
B. Correct. So can we write CD as B cos C? Can we write this?
Yes, sir.
Similarly, if I look at BD, what can I write BD as?
That could be um, that would be BD over H for cosine of BD or of B. So it would be
BD over H is
or BD over C. So it would be C cosine B for BD.
BD over H is cosine of B, correct? Right? Angle B is there.
Yes, sir.
The base or adjacent side is BD and the hypotenuse is AB or C, right? So BD, I'm sorry, not BD over H. BD over C is equal to
Yeah.
cos of B.
Yes.
So
So it's
BD is equal to C cos B.
yes.
Can I do this?
Yes, sir.
Yes.
So then what is BC? BC is nothing but BD plus CD, correct?
Yeah.
Yes, sir.
Can I write this? BC equal to BD plus CD?
Yes.
Okay. Now what is BD?
It's C cosine B.
C cosine B. What is CD?
B cosine C.
B cosine C. See the beauty of it? C cos B, B cos C, right? That gives me A, right?
Right.
You getting the logic? A is equal to C cos B plus B cos C. So what would be side B?
Side B.
Same logic. So when it
It,
is A, it is C and B, B and C. So when it is B,
right.
it will be A and C.
A
A cos
cosine
B
C plus
plus B cos A.
it's wouldn't for side B wouldn't it be A and C, not B and A?
I'm sorry?
For on the side B, it's A and
Yeah.
C, right?
See, on the side B, if I
So
drop a perpendicular like this, you will get the same thing,
yes,
right?
but what I'm saying is it should not be A cosine B. It should be A cosine C plus C cosine A.
Ah, you're right. A cosine C, I'm sorry. A cosine C and C cosine A. Correct. And C would be combination of A and B. A cos B plus B cos A. Right?
Yes, sir.
Okay. So now if I square both sides, I get A square is equal to C square cos square B plus B square cos square C plus 2BC cos B cos C. Can I write this?
Yes, sir.
I'm squaring this identity or this equation. Correct? So I can
Yes,
write
sir.
A square is equal to C square B, C square cos square B plus B square cos square C plus 2BC cos B cos C. This is equal to C square. In place of cos square B, I can write 1 minus sine square B, because cos square B plus sine square B is equal to 1.
Okay.
Do you know this identity?
No,
No,
sir.
I did not.
Okay. So this is where, there is a lot of intermixing of geometry with trigonometry, because geometry completely depends on trigonometry. So for the time being, since I have not touched trigonometry yet, just take it as an input. When we go into trigonometry, I'll show you the proof.
Okay, sir.
Okay.
Okay.
So cos square B plus sine square B is equal to 1. Therefore, it can be written as 1 minus sine square B. Similarly, I can write cos square C as 1 minus sine square C. And I leave the rest as is. Cos B, cos C. Right? So therefore, I can write this as B square plus C square minus C square sine square B minus B square sine square C plus 2BC cos B cos C. Right? I have just broken up the terms and rearranged them. Okay?
Yes, sir.
Kushal, can you follow?
Yes. Yes, I can.
Sorry?
Yes, I can.
Okay.
I follow.
Okay. So this can be written as B square plus C square. Now, what is C sine B? We know that B by sine B is equal to C by sine C. Sine rule, right? So
Right.
I can write B sine C is equal to C sine B, cross
Yes,
multiply,
sir.
correct?
Yes.
Can I do that?
Yes.
Yes.
So minus, this is C sine B whole square minus B square sine square C plus 2BC cos B cos C. Now in place of C sine B, I will write B sine C. So this becomes B square plus C square minus B sine C whole square would be B square sine square C minus B square sine square C plus 2BC cos B cos C. Okay?
Okay.
Are you able to get this?
Yes.
Yes.
Okay. So this can be written as B square plus C square. There are two terms which are having B square sine square C. So I add them up. Minus 2 B square sine square C plus 2BC cos B cos C. Okay.
Okay.
Now, B square sine square C means B sine C into B sine C, right?
Right.
And
Yes, sir.
B sine C again is equal to C sine B. So what I'm going to do is I
Yes.
am going to retain the first
Yes.
one, and in place of the second one, B sine C, I will write C sine B. So then B square sine square C becomes equal to BC sine B sine C. Okay?
Okay.
Are you able to follow this?
Yeah.
Sorry, I didn't get the last part, sir. I didn't hear you.
Okay. What is B square sine square C? B square sine square C means B sine C whole square. Correct? So that means
Yes.
B sine C multiplied by B sine C. Correct?
Yes, sir.
I keep the first term as is B sine C,
Yes, sir.
and I replace the second term B sine C with C sine B. Right?
Okay.
So this becomes BC
Yes.
sine B sine C. Okay?
Yes, sir.
Okay.
So this becomes minus 2 into BC sine B sine C plus 2BC cos B cos C. Okay? This can be written as B square
Yes,
plus
sir.
C square minus 2BC I take common. Okay? Sorry. Yeah, minus 2BC I take common, and I can write sine B sine C. Sorry, I will take plus 2BC common. It should be the other way around. Cos B cos C minus sine B sine C.
Yeah.
I can write this.
Yes, sir.
Yeah.
Now, again, this is a trigonometric identity. Cos B cos C minus sine B sine C is nothing but cos of B plus C. We will do this when we do the trigonometry part. Okay,
Okay, sir.
Okay.
so this can be written as B square plus C square plus 2BC cos of B plus C, right? And what is B plus C? B plus C
B
is
plus
equal to,
C is A.
1 second,
A.
1 second.
180 minus A.
1 second. Yeah. So B plus C can be written as 180 minus A because the sum of all three angles is 180.
Yes, sir.
So this can be written as B square plus C square plus 2BC cos of 180 minus A, right?
Right.
Can we write this?
Yes, sir.
And again, cos of 180 minus A is equal to minus cos A. We'll do all these identities when we go into trigonometry. So this is B square plus C square plus 2BC into minus cos A. So that is nothing but b square plus c square minus 2bc cos a. This is equal to a square. This is called the cos rule, cosine rule.
Okay.
Okay,
Okay.
this is called the cosine rule. And again, see, the logic is very, very clear. When I take a, it is a combination of b plus c minus 2bc cos of the included angle. Okay, the included angle of b and c
Okay.
is a,
Yes, sir.
right? Let's go back to the figure. So b and c are my two sides. The included angle is a. So when I'm trying to find out this side a, then I take the squares of the other two sides plus, or sorry, minus twice the product of these two into cos of their included angle. Why did I do all this? Because I want to solve case 3 and case 4, right?
Yes, sir.
Kushal, are you able to
Yeah.
follow?
Yes, I understand.
Okay. So just like we did sine, we developed a rule using cosine, which will help us deal with the other cases, which we were not able to deal with using the sine rule. Okay, this is the logic.
Okay.
So in the cosine rule, we get a square is equal to b square plus c square minus 2bc cos of the included angle. So therefore b square would be what?
C square plus A square
Then minus 2
minus 2AC
cos.
AC B.
Yeah. See, whenever the sides are A and C, the included angle is B. Whenever the sides are B and C, included angle is A. So C square would be
B squared plus A squared minus 2BA cosine C.
fantastic. So now you see that in the third case, when three sides are given, that means A, B, and C are all given. I can use any of these equations. A, B, and C are given. These two are given. I will get cos A, right? Which means I'll get A. Next, I use this equation. I will get cos B or B, and therefore I get C.
Okay.
Yes, sir.
So case 1 and case 2 would be sine rule. This would be sine rule. And case 3 and case 4 would be cosine rule. Cosine rule. See, in case 4, two sides
Hello.
and included angle given, right? So B, C, and A are given,
Right.
right? Combination is B, C, and A. So I use this equation straight away. I will get side A. And once I get one side, I can use the sine rule to find out the other two angles.
Right.
Is it clear?
Yes.
Yes, sir.
Any doubts?
No.
Okay. Let me also, since we are doing this, let me also show you one more thing. At least I can cover the one of the identities that I just used, which is sine square theta x plus cos square x is 1. Now, let us take a right angle triangle, ABC, okay? And this is 90 degree, right? So, what is
Right.
sine C?
That'd be CB over A,
Let us name these sides A,
or
B, and C. What is sine C?
C over B.
Opposite by hypotenuse, right?
Right.
Which is
C
the
over
opposite
B.
side of angle C?
C.
Prisha?
C.
C, correct. And which is my hypotenuse?
B.
B, correct. Kushal, you are able to follow this?
Yes.
Right? And what is cosine of C? Adjacent by hypotenuse, right?
Would be
Which is the adjacent side of angle C?
A,
A.
A. Hypotenuse is B,
B.
right? So what is cosine square of C? That is equal to cosine C whole square. That is what?
A squared over B squared.
A square over B square. Correct? What is sine square C?
C squared over B squared.
C square over B square. Correct? Now if I add these two, cos square C plus sine square C, then it becomes A square plus C square over B square. Correct?
Yes.
Prisha, you able to get?
Yes, sir. Yes, sir.
I'm just adding these two. A square over B square and C square over B square. So it becomes A square plus C square over B square. Now what is A square plus C square in this diagram? ABC is a right angle triangle.
Yes, sir.
So what is A square plus C square?
They are
B.
equal to B squared because
B square is equal
Pythagorean
to
theorem.
A square plus C square, Pythagoras theorem, right?
Yes, sir.
Yeah.
So in place of A square plus C square, I can write B square. So that is equal to 1. So therefore cos square plus sine square is always equal to 1.
Okay.
Yes, sir.
Clear?
Yes, sir.
Yes.
Kushal, clear?
Yes.
Okay. I will do the rest of it later because that will need some more trigonometry involved. So I'll not go there right now. But I'll show you one more thing, one more simple thing. So, so if I say this is C, angle C here as X, angle A would be how much in terms of X?
It would be 90 minus X.
90 minus X. Prisha, you got this?
Yes, sir.
Okay. So if I take cos of angle C, which is cos of X, that is A over B, right?
Yes, sir.
Right? And if I take sine of angle A, right? That is sine of 90 minus X. That is also equal to A over B, opposite by hypotenuse.
Yes, sir.
Side A is opposite to angle A. So therefore,
Yes.
sine of A is A by B here. Kushal?
Yes.
Okay with this?
Yep.
So therefore, I can see that cos of x, which is equal to a by b, is equal to sine of 90 minus x. So cos of x is equal to sine of 90 minus x. So in general, cos of any angle is equal to sine of 90 minus that angle. Okay?
Okay, sir.
And if you do the reverse thing, if you take sine of x here, right, and cos of 90 minus x, you will see that sine of x will be c by b and cos of 90 minus x will also be c by b. So the reverse is also true. That means sine of any angle is equal to cosine of 90 minus that angle. Okay,
Okay.
clear, Trisha?
Yes.
Yes, sir.
Okay. So we will do the cosine a plus b later on. That's the only thing that I didn't cover here. Okay. Now get back to triangles. So now we have understood how to find out the sides of and angles of a triangle. Now let's look at area, which is the next important thing. So in how many ways can we find the area of a triangle? So the simplest way is what?
1/2 base times height.
Correct. So if I have my height like this, so area of triangle is half base into height. This is the simplest one, right? Half base
Right.
into height. What else can we do? What other way can we find out? I showed you one more technique yesterday.
I do not recall.
So
Half the sectional. No, wait.
So if I look at angle
Would
C, then sine of C is equal to h over b, opposite by hypotenuse,
right?
right?
Yes, sir.
Yes.
H over b, correct?
Yes.
So I can write h as b sine C.
Yes, sir.
Yes.
So
Okay.
I
So
can
1/2.
write, I'm sorry?
1/2 base times b sine c.
Yeah, and I have taken a as the base here. So a into height, which is b sine C.
B sine C.
Again, look at the beauty of it. AB with sine of C. AB sine of the included angle. Half of that. Clear?
Yes.
And so by similar logic, this can be written as half. Oh my God. My computer is giving a lot of problem today. Okay. So I can write this as half BC sine A or half CA sine B. Clear?
Yes, sir.
You take any two sides, product of any two sides, and the sine of the included angle. Right? So this can be done with any combination. Okay. So case 1 is base into height. This we use when one side plus height is given, then we can straight away use this formula. This formula can be used when two sides and included angle given, right? Two
Yes, sir.
sides and included angle. What else can we do? What is the other way of finding area? Root over S into S.
SS minus A into S minus B into S minus C.
This is called the Heron's formula, the one that you were talking about yesterday, right?
Hmm.
Right? And this
Yes.
can be used when all three sides are given, no angles, right?
What is S in this case? Would that be H?
Perimeter A plus, it's A plus B plus C divided by 2.
A plus
Oh,
B
okay.
plus C by 2. S is called the semi-perimeter. Okay, that is half of the perimeter. Semi means half. Half of A plus B plus C. Okay. Unfortunately, the proof of this formula is beyond your scope, because there is slightly more advanced mathematics involved, which is why I'm not getting into this. Okay.
Yes, sir.
Okay. So this is the third way. Is there any other way by which we can find the area of a triangle? Do you know of any other way,
No, sir.
Kushal?
No, I do not.
Okay. There is one more way. I'll show you what. So let us take the triangle again. ABC, and we have a circle inscribed in the triangle. Let me draw this properly. Okay, so this is my triangle, and let me draw the circle here. Okay.
Yes, sir.
So what is this circle called? The circle which touches three sides of a triangle inside it is called the inscribed circle or incircle. Okay. Kushal, are you able to follow?
Yes.
So this is the inscribed
Sir,
circle.
could you please repeat that?
Yeah.
Achha.
So any circle which is drawn inside a triangle which touches the three sides of the triangle is called inscribed circle. Circle
Okay.
drawn inside inside a triangle which touches touches the sides of the triangle. This is called inscribed circle or incircle. Okay.
Yes, sir.
Now let us assume O is the center of this triangle, of this circle. Okay. So if I join these 3 points, right? Let us say these points are D, E, and F. Then what is OD?
Radius.
Radius. OD is equal to OE is equal to OF. All of these are the radius of the circle. Correct?
Yeah.
Yes, sir.
Kushal?
Yes, I follow.
So all of these are radius of the circle. Right? And what else? It is the radius of the circle, and each of the sides is a tangent to the circle. Each side
Yes.
of the triangle are tangents to the circle. Correct?
Sir.
That we can see very clearly. That is the definition. Right?
Yes, sir.
And
Yeah.
what is the property of a tangent?
So FB will be equal to BD.
Sorry? F?
B will be equal to BD.
No, I'm not going there. I'm not going there. Hold on. I'm not going there. I'm only asking
Okay.
what is the property of a tangent to a circle?
A tangent line intersects the circle
There is
one
only
time.
one property of a tangent, which is it is perpendicular
To the
to the
point of
Radius.
radius.
contact with the radius.
Okay, it is perpendicular to the point of to the radius, and I'll do the proof when we go into circles. Okay, there is a very simple proof for this. Okay, so this is 90, this is 90, this is 90. Okay,
Okay.
so now I just join these 3 points to the center. Right now you can see that in triangle. Now I've divided the big triangle into 3 triangles. Right, in triangle AOB, right, the area can be written as half of AB into height, which is OF. Can we write?
Yeah.
Yes, sir.
Similarly, okay, we can name the sides as usual. We'll call this A, B, and C. So AB is C. So half C into R. OF is R. So what would be the area of triangle AOC? Half AC into OE. Correct? Are you able to follow,
Okay. Yes.
Prisha?
Yes, sir.
Half AC into OE, right? That is the area of triangle AOC. Right? What is AC? AC is nothing but B. Oops. My God. What's happening? Okay. So half of AC means B and OE is again R, correct?
Yeah.
Kushal,
Yes.
you able to follow this?
Yes.
Okay. And similarly, the third triangle, which is BOC, can be written as half BC into OD, right? What is BC? BC is A and OD is R, right?
Yes, sir.
So if I add all of these three triangles, I will get triangle ABC, the area of triangle ABC, that is equal to half R into A plus B plus C, right?
Yes, sir.
Half R into A plus B plus C. That means we can calculate the area of a triangle in a fourth way, which is half into perimeter into in radius. Okay.
Yes, sir.
So if I give you the perimeter, I don't tell you the sides. I just tell you that the perimeter of a circle of a triangle is 20 centimeter and its in radius is 15 centimeter. What is the area? You get what I'm saying?
Yes, sir.
Yeah.
Is it clear?
Yes,
Yes,
it
sir.
is.
So this is the fourth way in which you can be asked to find the area of a triangle. This is a tricky one because in the exam when you get a question like this and you see nothing is given, no side, no angle, I'm just told the perimeter and the in radius, what do I make out of it? So this is what you have to make out of it. Okay. This is what would be required. Clear?
Yes, sir.
Kushal, are you able to follow?
Yes, I am.
Okay. So this is the basic uh, part of a triangle, which means how to calculate area, how to calculate each side and angle, how to calculate the perimeter, all of that. These are the basics, right? Now we have to get into the properties of triangles. There are some very, very important properties that we need to understand. Okay. So let me again draw the triangle first. ABC. Now, the first property is the median. What do you mean by the median? Median means a straight line which joins the midpoints of two sides of a triangle. Median is a straight line joining the midpoints of two sides of a triangle, right? That is the median.
Right.
So we have taken D and E as the midpoints of AB and AC, right? And we are also given uh, the value of the side A or BC, and we have to find out the length of DE, which is the median. How will we do it?
By midpoint theorem,
What is that
we
theorem?
can extend C parallel to BD and then extend DE, and the point where they meet will be F.
Hmm. Like this, right?
Yes, sir. Then
Okay.
AED and FEC are vertically opposite angles.
Hmm.
AE is equal to EC because it's dividing that side into two equal parts.
Hmm. Right.
And then DAE and ECF are corresponding angles. No, wait, are alternate angles.
Yes.
So by ASA,
So
these triangles,
these two triangles are congruent, correct?
yes, sir. Then AD will be equal to FC, and AD is also equal to DB. So DB will be equal to FC.
Right.
This becomes a, so they are equal also, and this becomes a parallelogram.
Yes.
So DF is equal to BC. So half of DF will be equal to half of BC. So BC will be equal to 2DE.
Fantastic. Kushal, were you able to follow this?
Yes, I am.
You able to follow this?
Yes.
Okay. So any median will be half of the third side, and it will be parallel to it. Okay. Clear?
Yes, sir.
Okay. This is one important property of a triangle. And the other important property is we did the incircle, right? We just now did the incircle, correct?
Yes, sir.
So if I draw the incircle, then we just found that the in radius is equal to what? That the area of the triangle ABC is equal to half in radius into A plus B plus C, right? Right?
Yes, sir.
And if I write A plus B plus C as by 2 as S, which is a semi-perimeter, then area of triangle is equal to in radius into semi-perimeter. So in radius is area of triangle by semi-perimeter. This is another important property.
Yes, sir.
Kushal, you got it?
Yes. Yes.
We just proved that the area of the triangle is equal to half in radius into A plus B plus C. We just did it a while
Right.
ago. And from there, I'm writing A plus B
Yes.
plus C by is equal to semi-perimeter S. So therefore, triangle area of triangle is equal to in radius into semi-perimeter. So in radius would be
Right.
area of triangle by semi-perimeter. Okay.
Okay.
So this is a very common question in exams. You will be asked to find the in radius of a triangle. Okay.
Okay.
The next one is circumradius. Now, how do we deal with this one? Let me draw triangle Okay. Now, when we are talking about circumradius, that means circumscribing the circle, circumscribing the triangle, right? So it will touch all the 3 points like this, right? So this is my circumradius. Uh, cir circumscribed circle is called circumcircle, and the radius of
Yes,
that
sir.
is called the circumradius. So we have to find the circumradius now. So let the center of the circle be O. So we do the same thing. We join the 3 points to the center. We join the 3 vertices to the center, right? Next,
Yes, sir.
this is called capital R, and in radius is called small r because the circumradius is always greater. Okay.
Yes, sir.
So how will we find out the circumradius? Tell me. How do we find the
BC
circumradius?
lies BC is lying on the radius.
BC is not lying on the radius. No, no, no. is not lying on the. BC is not a diameter.
Okay.
See, if remember this, when we go into circles, we'll do this. If you have a diameter, it would always make a 90-degree at any point on the circumference. So unless angle A is 90-degree, BC cannot be the diameter. Okay, this is a property of the circle that we'll do when I get into circles. But
Yes,
to
sir.
answer your question, BC is not the diameter. So how do we proceed? What is the logical step? What did I do last time? What did I do last time?
Could you extend one of the radiuses to make a perpendicular?
You want to extend the radius. Okay, if I extend the radius, fine. Then what?
No, never mind. That
See,
wouldn't give
extending the
us any
radius will not
information.
help because it will not be a 90-degree.
Right.
Always remember when you are dealing with triangles, right? And combination of triangles and other figures, especially circles. What you have to do is look at ways to bring in right angles, right? Because that will give you an equation with the area. The only property of a only two properties, basic properties of a triangle are perimeter and area. Correct? So we have to
Right.
relate
Yes, sir.
R to one of these two. See, last time in the case of incircle, we related incircle to both perimeter and area. Correct?
Yeah.
Yes, sir.
Same logic. Exactly same logic. Right? So how will we relate this to one of these two? May not be both. Either perimeter or area. So perimeter or area means we have to drop a perpendicular.
Perpen. Hmm.
Right? So now if I drop perpendiculars on both sides, what do I get? What do I get? Let us name these points.
You get a rhombus.
Sorry, come again?
You get a rhombus.
We get a rhombus. No, we don't get a rhombus. How are you saying we get a rhombus? In a rhombus, all four sides are equal. So AD and AE, are they equal to OD and OE? No.
Okay.
Even OD is not equal to OE. Right?
Right.
That. Now look at the triangles AOD and AOE. What can you tell me about these two triangles?
They both are right angle triangles with the same hypotenuse.
Okay, before I get there, no, this will not help. Tell me what you can tell me about triangle AOB. What can you tell me about triangle AOB?
Its area is 1/3 of the whole triangle.
No, because I've drawn it very symmetrically, it looks like that, but it is not. What is triangle? What can you see in triangle AOB?
It's got one obtuse angle.
Come again?
It's got one obtuse angle.
No. See, in triangle AOB, AO is equal to BO, which is equal to R. Correct?
Yes.
What
Yes,
can you
sir.
tell about triangle AOB?
It's an isosceles triangle.
Fantastic. It's an isosceles triangle. So what is the property of an isosceles triangle?
B and A will be equal to each other. Angle angle OAB and angle OBA will be equal to each other.
So you got this?
Yes.
Now look at triangle AOD and BOD. What can you say about these two triangles?
AOD and AOB, or BOD, they are the same. They're similar triangles.
Sorry?
They are similar triangles.
Is it similar? They are definitely similar, but there is something
they
more
are
to
the
it.
same because they've got the same. One of the legs is the same.
These two triangles are congruent. Why?
Right. So two of the angles are the same, and two of the sides are the same. So all three angles must be the same.
All three angles are same, and we have these two sides equal, right? So
So
angle
Right.
side,
SAS.
you can use angle side angle, and the side OD is common or reflexive, right? So we have
Right.
two sides equal, all three angles equal, so we can use side angle side angle, or right angle hypotenuse side. Right
Yes,
angle,
sir.
hypotenuse, and side, right? So triangles are
Yes,
congruent.
sir.
Triangles are congruent. That means
Yes.
Yes, sir.
AD is equal to BD.
Yes.
So D is the midpoint, right? This is a property of any isosceles triangle. If I have any isosceles triangle, ABC, where these two sides are equal, and if I drop a perpendicular, right, that will divide the third side. Basically the same thing. Right angle, hypotenuse, and side congruency. Okay.
Yes, sir.
So that means we have two congruent triangles where point D divides AB into two equal halves, right? So we call these two angles X and X. Similarly, if you look at triangles AOE and COE, right? Then what happens? Same logic. These two angles become equal, right?
Yes, sir.
Correct? And by the same
Yep.
logic, if I drop a perpendicular here, by the same logic, these two angles are equal. Correct?
Yes, sir.
Yeah.
Kushal, you able to follow?
Yes. Yes.
Okay. So that means we have three triangles where we can see that there are three pairs of angles. Now we have 2x plus 2. If I add up all the angles, 2x plus 2y. Oops. If I add up all the angles of the bigger triangle, so 2x plus 2y plus 2z is equal to 180.
Yes, sir.
I'm just adding all the angles in triangle ABC. Angle A plus angle B plus angle C. Right?
Yes.
Yes.
So x plus y plus z is equal to 90 degree. Correct?
Yes, sir.
Yep.
Okay. Now we have to equate it to the area. Right? So in how many ways can we calculate the area? I showed you 4 ways, right?
Yes,
Right.
sir.
So in this case, assume that you know the sides A, B, and C. Okay. So A, B, and C are
We
given.
can
Yes.
use the
So we can use the formula
use
S into S minus A into S minus B into S minus C to calculate the area of the triangle, right?
Yes, sir.
Now, how do I bring in R now? That is the question. How do I bring in R? So again, we will use the other rule, which other way of calculating the area, which is
Half into base into height.
half AB sine C.
Okay.
Okay, half AB sine C,
okay.
right? Half AB sine C is we just did that, right? Using um, the
Right.
sine rule, we can calculate the area of triangle in this way,
Yep.
right? So if I do this,
Yes, sir.
half AB sine C, what is C? C is y plus z.
Yes.
Half AB, what is y plus z?
90
90,
minus
90
x.
minus x. right?
Yes, sir.
90 minus x. What is sine 90 minus x?
Cos x.
Cos x,
Yes,
right?
sir.
How do I calculate cos
Yes.
x? Look at the triangle AOD. Here we have 1x, right? So cos x
Right.
is equal to adjacent by hypotenuse. What is adjacent
Yes.
to x?
AD.
AD. Hypotenuse is?
AO.
R.
R.
I have brought in R now. Okay. What is AD? AD is, we just proved AD is the midpoint of AB. So AD is
Right.
C by 2,
Yes.
right?
Yes.
So this can be written as half AB. In place of cos x, I will write C by 2 over R. I can do that,
Yes.
right? So this is 1 by 4 ABC over R. So therefore
Yes.
R is equal to ABC by 4 times area of the triangle. Clear?
Yes, sir.
Yes.
Kushal, is it clear?
Yes.
So this is again a very, very important property of the triangle where you can be asked to find the radius of the circumcircle. Now, one more thing, let me tell you here. What are the different ways that they can ask you? So they might give you two sides, let's say AB and any other angle, let's say angle A. So you straight away use the sine rule to find out C, right? So this is case 1. So you are given this combination. You use the sine rule to find out side C, and then you can use this one straight away, right?
Yes, sir.
Case 2, you can be given AB included angle, which is C. Then what do you do?
You find
What do you do?
Cosine rule.
So this is a tricky one, okay? So if you are given this combination, use the rule AB sine C to find out the area of the triangle first, which is your denominator, right? Correct?
yes.
And then
Yes.
use the cosine rule to find out side C. Okay?
Yes, sir.
That will give you the numerator. Clear?
Yes, sir.
Kushal, is it clear?
Yes.
And the third combination is you're given all three sides, which makes life very simple for you. Then you can straight away use this rule. Use the formula root over s into s minus a, blah, 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 to find out your denominator, and ABC is given. So straight away you can find out the radius. Okay.
Yes, sir.
Yes.
Is it too heavy for today?
No.
Was it too heavy? Was it too fast?
No. It all makes sense.
Prisha,
Yes, sir.
was it too fast?
No.
Okay. Don't worry, we'll definitely revisit all these concepts, because when we get into problems, right? When we start working on problems, we will discuss, will obviously revisit all of this, right? Uh,
Yes, sir.
so these are the basic important properties of a triangle. There are a couple of more which we will discuss tomorrow.
Okay, sir.
Okay,
Yes, sir.
Okay.
Kushal, is it okay for you?
Yes.
Okay. Prisha, when do we meet tomorrow?
Sir, I'll have less classes tomorrow. I'll inform.
I think keeping it
I'll
in the,
check.
no, I think keeping it in the evening will help Kushal, because it's otherwise too late for him in the night,
Yes.
right? So I think
Okay.
this is a very convenient slot for all of us, right, Kushal?
Okay.
Right, Kushal?
Yes.
Okay. So let's keep it at this time, 5 to 6 p.m. India time and 6:30 to 7:30 a.m. Central time, right?
Yes.
Okay. And as you have seen, I have sent you a exercise on Quizstar. So you can complete it, and then we will discuss that.
Sir, I have one doubt
Yeah.
of arithmetic progression. So there was this example in the book. A pair of rabbits.
Can you do one thing? Can you share it on Skype? Take a screenshot and share it here.
Assuming no rabbit dies, the number of pairs of rabbits at the start of the first, second, and third till the 6 months are. It's an example.
Yeah.
How do
Just
we solve this?
yeah. Can you just take a screenshot of that and put it here in the chat so that I can see the problem?
Okay.
Just take a screenshot and put it here. Yeah. No. Take the screenshot of the problem.
Yes, yes. It's not on the computer actually. It's in my book.
Uh, just take it on your phone. Just click a
Okay,
photo and
wait.
you can
Okay. Okay, wait. Let me put it then.
see. This is the advantage with Skype. You can share anything, and it's very easy to exchange files and all.
My phone is discharged, sir. I'll put it after you end it. I'll take my mom's phone. She's downstairs, and then I'll
Okay,
put
no
it.
problem. Can you just type the question here?
Okay.
So, Kushal, this is for you also. If you have any doubts, in any other topic beside the one that we are discussing, you can always share it, and we can discuss it out here.
Okay. Um, School's going a bit slow for me right now, so
Or
don't really
you
have
can
anything
also
yet.
use our WhatsApp group, and you can post it there, and I'll check and respond.
Okay.
And as she's typing, I think you would have seen my post today. There is a YouTube channel that we have, and there are good videos out there, so you can go through them at your convenience. There are a lot of problems which are solved, and concepts that are discussed with other groups which I have posted there.
Okay. I will look into it.
Don't have to type the whole thing, Prisha. Just type the key figures. That should be good.
Oh, I almost typed it.
Okay. Ah, here it goes. Okay, let's get this one. Up. Okay, a pair of rabbits are too young to produce in their first month. In the second and every subsequent month, they produce a new pair, and each new pair in the second month and every subsequent month.
Each
Assu-
new pair produce in their second month and in every subsequent month.
yeah, it's a repetitive thing. Okay.
Yeah.
Assuming no rabbit dies, the number of rabbits are at the start of the first, second, 6 months respectively are okay. So this is actually a problem on geometric progression, okay, which we haven't done yet, but I'll
Okay.
tell you how to do it. Okay, so there are
Yes, sir.
two rabbits in the start, right?
Yes. One pair. Okay.
One pair,
Hmm.
two rabbits, right?
Hmm.
And month one, nothing happens. Month
Hmm.
two, right? In the
Yes.
second month, they produce one new pair. That means 2 plus 2 or 2 square, right?
Yes.
Every subsequent month they produce a new pair, right? M3. The first pair will produce another pair, so it becomes 2 square, right? And the second pair
Yes.
will produce another pair. So
No, but that is their first month. That will be 2. The rabbits that are born in M2 will not produce in M3.
yeah, each new pair in the second month. So they're born in month 2, right? Second month is
Hmm.
month 3. See, in the second and every consecutive month,
Hmm.
right? Similarly, each
Yes.
new pair in the second and every consecutive month.
Hmm. Yes.
So the first pair in month 1 does nothing. In second month, they produce one pair, so it becomes 2 square, right? Now
Yes.
that is 2 plus 2. Now this first pair will produce another pair. The second pair will produce another pair, right? In the third month, correct?
Okay. Okay.
So this becomes 2 square plus 2 square means 2 cube, right? Month 4,
Yes.
this becomes 2 to the power 4, right? And so
Yes,
on.
sir.
It goes on, right? So month 6 would be 2 to the power 6, right? So at the start of the first, so the question is, you have to find out how many rabbits are there at the start of each month. So start of month 1 is 2, month 2 is 2 square, month 3 is 2 cube, month 4 is 2 to the power 4, month 5 is 2 to the power 5, month 6 is 2 to the power 6.
Okay.
Okay,
We
so
could set
as soon
this
as
up.
the month ends, that means the next month begins, they produce a pair.
Okay.
Clear? So we are
Yes.
taking all of this as the starting of the month. So starting
Okay.
of first month we have 2. First month ends, second month begins 2 square. Second month end, third month begins 2 cube, and so on.
Hmm. Yes, sir.
So the numbers would be 2, 4, 8, 16, 32, and 64.
Okay.
Clear?
Yes, sir.
Anything else?
No, sir.
Don't worry, we'll come to geometric progressions when we do progressions.
Okay.
I have another way we could solve this.
Kushal, you have any
So,
doubts?
no, but another way we could do this is we could have it be, so, like, it could be some algebra where it's y equals b to the x minus 1. And that would be the exponential function that it follows.
Yeah, you can do
Because,
that. You can do that.
and that would tell us how many pairs, because at the end we don't have 64 pairs, we have 32 pairs. But there are 64 rabbits.
You are getting 32. That means you are assuming that it starts from month 3.
No, what that means is that it's 32 pairs of rabbits. You found 64 rabbits because in month
Oh,
one
yeah, yeah,
there
you're
are two
right.
rabbits,
So,
there are one pair.
yeah, absolutely right. I'm sorry. Yes. So this is 1, 2. Yes. Now, if number of pairs we count, yes. They're asking number of pairs. Absolutely right.
Yes, sir.
16 and 32. Thanks for pointing this out. So I calculate the total number. Yes. Absolutely right. So this would be the number of pairs that will exist.
Yes,
Okay.
sir.
Okay, so that's all for today. We meet same time tomorrow, and if you have time, you can go through the exercise that I have given. I'll try to roll out one more exercise on triangles. Okay. Okay.
Yes, sir.
Okay. Kushal,
Yes, sir.
have a nice rest of your day, and Prisha,
Thank
have
you.
a good evening. We meet again tomorrow.
Yes. Thank you, sir.
Thank
Thank
you.
you.
Bye.
Bye.